Alright, in this video we're going to take a look at arithmetic series. So last day we took a look at sequences and we learned that a sequence is a list like 3, 5, 7, 9, where if it's arithmetic you have a common difference up to each time. Well, a series is a lot like your list, except you just add up your list. And so we call that a summation in math. So you take 3 and 5 and 7 and 9 and maybe some other numbers and you just add them up. And then the trick or the question that comes out of this is, well, how do we go about adding them up quickly? Because if you know how many terms are in this list, or you know the biggest number in the list, there are ways to add these up so you don't actually have to do 3 plus 5, get 8, plus 7, plus 9, etc., etc., etc. Well, let's take a look at an example, and this is actually got a little bit of history behind it, but how do we add up the numbers 1 plus 2 plus 3 plus 4 plus 5 all the way up to 99 plus 100, all the way up to 100? And there was a famous mathematician, some of you might recognize this name, named Carl Friedrich Gauss. And supposedly he was in elementary school and he was very, very, very smart. And I guess a little bored in class maybe sometimes, and he was getting in trouble one day, and the teacher said, "Carl, if you don't stop being in trouble, everyone's going to have to do extra work." And of course he couldn't help himself, and the teacher said, "That's it, everybody sit down and add up the numbers from 1 to 100 by hand." And so everyone complained, but they got their pencils out and they started adding 1 plus 2 is 3 plus 3 is 6, and they had just learned how to add and carry. And of course you may recognize that this number gets quite big, and when you're adding the sum and then adding 67 and then 68 and on and on and on, it gets quite tedious to do. Well, about 2 minutes later, Carl walks up to his teacher with the answer, and the teacher of course thinks that he's just joking around and probably gives him a detention or some such thing, and of course gets really mad. But of course he had the answer, and this is Carl's way of doing it, and then we'll expand on that to get a way for us to do this. So he thought about this as, okay, I'm going to calculate the sum, I'll call it S. So if I add up 1 plus 2 plus 3 plus 4, it adds up to something, and the algebra is, it's the sum. And that sum is exactly the same as if you reorder it in the opposite order. So 199 and 98, 97 and 96, all the way along to 321. And he thought, well, let's just add them up this way, so I get two sums. So one sum is this, another sum is this, I get two sums. And then I'll add these ones up, I get 101, and I add these ones up, I get 101, and I add these ones up and I get 101, and crazily enough, you get 101 a lot of times, all the way to the end of the list. And then he thought, well, I can get the answer to 101 plus 101 plus 101 because I know how many times this is. This is 101 100 times, because you counted from 1 to 100, there must be 100 times that you've just added up 101, and he knew that 101 times 100, you just add a couple of zeros. So now he knew what 2s was worth, and it's not very difficult to then go and divide by 2, so he got his sum of, instead of 10,100, he got 5,050, and that's the number he took to the teacher and got scolded for. Well, Gauss was definitely onto something with this, and we actually use a formula very, very similar to this to solve these sorts of arithmetic series. And the formula is, if you want to know the sum of n terms, in this case 100 terms, you need to know how many terms there are, in this case 100, and you'll divide that by 2. You can see kind of why you do a division by 2 here, and why you need 100 times. And then you need to know the first number, 1, and add the last number, 100. So n is the number of items in your list. Of course, S sub n is the sum of n terms. A is the first term, and L is the last term. So if you know those things, you can actually find these sums fairly quickly. Just plug those letters in and you can solve. Now, with a little bit of algebra to this, we can get another formula that also works quite nicely. So last day we saw that the nth term was a plus n minus 1 times d. Well, now we're dealing with the last term. The nth term is kind of the last number on our list. So that last term is a plus n minus 1 times d. And so now I know what that last term is worth. I can take this piece of algebra here and I can put it in for that L. And let me just rewrite that and show you what I mean by that below. So I get S sub n is equal to n over 2 a plus, but instead of L, I'm going to have another a and then times, another a plus n minus 1 times d, and that can simplify a little bit. I get n over 2, and inside here I have two a's and plus n minus 1 times d. And what's really nice about this formula, and let me just rewrite it as S sub n, n over 2 2a plus n minus 1 times d, is this formula here doesn't require you to have that last term. Instead, this formula here lets you just know the common difference. So sometimes when you're working on questions, you need to sum up something that has the information of n, a, and l given to you, and you can use this first equation, and sometimes you don't know the last term in particular, and so you can use this other equation, n over 2 times 2a plus n minus 1 times d, to solve these questions. So you do have to think a little bit as you're going through these questions, which of these do I want to use? So let's do a couple of examples, and we can pick and choose which one we want as we go. So for this first example, let's see if we can find the sum of the first 25 terms of the list that goes 11 and 15 and 19 and on and on and on and on. Now you can see we don't have the last term, so I don't really want to be using the formula that involves the last term. So let's just immediately write down that we're going to be using the other formula. A real strategy with this is to figure out which formula you're going to use, write that actual formula down, then you can go and substitute things in. So I'm calculating the sum. I'm actually calculating the sum where n is 25, so the sum of 25 terms, and that tells you that n is 25, and I need the a value, and I need the number of terms, which is 25, and I need the common difference. So this is up by 4, check, yep, up by 4, up by 4, up by 4, and now it becomes a calculator problem. So you just grab your calculator, do 12 divided by 2 times, and then use brackets properly and get all the other numbers, and you'll get a solution of 1,475 in this case. Okay, let's take a look at another example. And if you are anticipating, you could maybe guess that I am going to do one here where I know some of the terms and I know the last term as well. Let's see what that might look like. Okay, here it is. Find the sum of 8 plus 1 plus negative 6 plus all the way down to negative 335. So this is down by 7 and down by 7. So I know my d value is down by 7. I know my a value is 8. I don't know my n value, so that could be a little bit troublesome, but I do know my last term. My last term is negative 335. So it's probably a good thing that we could, or a good one time now, to use n over 2 times a plus l, to use this formula, and that was from Gauss's first work there. And let's see what we can put in. The sum of these n terms is, well, I don't know my n, but I know my first term is 8, and I know my last term is negative 335. Well, I do need to go and solve for n, and we do luckily have a formula. T sub n is a plus n minus 1 times d that we used in the last section to solve for n when we knew the other things. So this is the nth term, negative 335. Or the last term in this case. This is 8. I don't know my n, but I do know my common difference is negative 7. And so I could subtract 8 and get negative 343. And on this side I could get negative 7n plus 7. I could subtract another 7 and get negative 350 is negative 7n. Dividing both sides by negative 7 will let me know that my n is 50. And so now I can know that I'm summing up the first 50 terms, and I can put 50 in for n and calculate 8, and then plus minus is just minus 335. And again, use my calculator to get the sum of the first 50 terms, which is negative 8,175. Okay, we'll get lots of practice in class, and we'll see you there.